Hi folks, in this section we are going to talk about a very important diagram in astronomy, and it's called the Hertzsprung Russell diagram. Now in 1910, two very prominent astronomers, N. Hertzsprung and Henry Russell, both independently graphed some information. They graphed the brightness of stars on one axis versus the temperature of stars on another axis. By doing this, they found that stars had a tendency to collect in very specific places. And since then, these diagrams are very useful for us to determine the type of stars and the life cycle of stars. So this is called the Hertzsprung Russell diagrams. They are often abbreviated as HR diagrams because Hertzsprung Russell is a lot to write down. Now, on one of these diagrams, across the x-axis, top and bottom, is the temperature of the stars, indicating the hot stars on the left, the cool stars on the right. This corresponds to the spectral types, "Oh, be a fine girl, kiss me," stars down below. So temperature or spectral type, they are directly related, and they are on the two x-axes. The y-axis, or the up and down axis, is the absolute magnitude of stars, which is the brightness of the star. How bright it actually is, not how bright it appears. This refers to, or this is directly a correlation with luminosity. And luminosity, remember, is the oomph of a star. This is how bright it actually, how much energy it gives off. So stars that are at the top of the diagrams here give off lots and lots of energy, and they have a tendency to be very bright. Stars in the lower areas have a tendency to be dim and very, very low energy stars. So that gives us different quadrants or different regions of this graph. And we're going to do a whole lab on Hertzsprung Russell diagrams. So you can spend a lot of time analyzing these pictures. So we have highly energetic cool stars up here. We have hot bright stars over here. We have dim hot stars in this corner, and we have dim cool stars in that corner. Now, when Hertzsprung and Russell each independently created this diagram, they found something that was absolutely fascinating. They found that most stars had a tendency to fall in a region that has since been named the main sequence. The main sequence is kind of like a river running through the center of this diagram, and this indicates where most stars actually fall. Now, the stars in this main sequence are actually referred to as dwarf stars. Our sun is actually a dwarf star. It's not a giant star, it's a dwarf star. So through the center you have the main sequence. Lower left-hand corner, that's where white dwarf stars tend to puddle. There are red giant stars and super red giants that are in that upper right-hand quadrant. And as we go through the life cycle of stars, stars will actually change their position on the HR or Hertzsprung Russell diagram as they change through different stages of life. The one property that determines where a star is going to be on a Hertzsprung Russell diagram is the star's mass. Whether it's going to be in the upper part of the main sequence, up here with the blue stars, in the middle of the main sequence with the white and yellow stars like our sun, or it's going to be in the bottom right-hand corner where the red dwarfs exist. So mass is a really big determining factor on how bright a star is going to be, how hot it's going to be, how much energy or luminosity it's going to give out. And this Hertzsprung Russell diagram, slightly different than the last one. I want you to see a variety of them. They all basically show the same thing, but they show it in a slightly different way, sort of like there are many ways to draw a periodic table. Same thing with Hertzsprung Russell diagrams. So big point, like put a star by it. It's probably going to be on a test someplace. The one factor that is going to have the biggest impact on how a star looks, how a star behaves, is its mass. That is also going to determine the life cycle of the star, how it's going to live and how it's going to die. And in a future chapter, that's exactly what we're going to go through. We're going to go through the various life cycles of stars. This is a beautiful illustration right here because it shows different size stars, very big ones, very little ones, and they have different life cycles. They do not all have the same kind of birth and the same kind of death. All right, that is going to finish our brief discussion of Hertzsprung Russell diagrams. And as I mentioned, we are going to do an entire lab on them, so you're going to get a lot of experience. See you later.